Okay, that is the microcontroller. This is the one. How many legs? You can see that from the green connector. You can see the legs of the microcontroller. Each of the legs have different functions. So, do not need to memorize all, but what you need to do is to understand the concept and its function. Because every time you learn the class, you can understand better on the pins on the microcontroller. So what does it mean all about this one? So we are going to talk about all this one. Okay, this is start of the microcontroller projects. I cannot run this one, but this is actually a spider. A mechanical spider. I cannot run the project, I don't know why. Maybe it's not embedded. But this spider, it can move around. If you can see on the spider, there are lots of motors over there. This is a motor. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, plus 3, 14 servo motors. It's controlled by the microcontroller. Okay, so that is a type of function that can be used for the microcontroller. Have anybody look at the robot line follower? Anybody have seen it before? So that is a competition. I just showed you what happened last year, last 4 years ago. Competitions that we have last time. This is the line follow robot. We have the competition around our class. So you can see that this is the type of the microcontroller used. So the task is to make sure that you can run on the line and go back and make sure that you can park inside the box. You must park. You are not allowed. So that's the first one. We have another round. So this is the second round. You see this one? This is a box. This is a box. And you have the wall. You have to make sure that it cannot touch the wall and must return back to the original position and stop. Which sensor? There are two sensors over there. One is the IR sensor, another one is the sonic sensor. There are two sensors used in that particular program. Okay, so that is actually at the end of the class, so we just started. So you have to learn a lot, right? Oh, before that, just a quick one. There is no specific reference for the microcontroller, so we come up with module. This one since 2011. So the cost is around 15 ringgit, 15. If you guys interested. So this is actually the whole syllabus covered will be covered, which is actually from the course letter that used to teach microcontroller. So you have the examples here, you have majority of the explanations because we do not have dedicated textbook for the microcontroller, that's none. So we have to do it ourselves. Alright, so this is the one. Later you can talk to me if you want. So that is the one. When you learn microprocessor, you can see that you learn about this guy only. This is the one that you're going to learn this round. It's actually something that you put all in together. So it comes out at the end this packaging. If you remember the microprocessor 68K is very big one, right? Big one. That is full technology. The faster, the latest one should be a smaller packaging. Okay, so this is the one. You can see that from here, you have the CPU inside here. You have all the modules also inside this chip. Whereas CPU you learn is only about CPU. You program on this one and you have all these things together outside. The CPU is only the brain, but this one you take the whole body and the brain, program it, and you can use it. Right, that is very simple difference on the CPU versus the microcontroller. Right, you can see that one, the difference. This is the things that can be used for the microcontroller. Vending machine is one of the systems that use microcontroller. Vending machine, because a lot of vending machine you need to put money over there. They have to do all the programming over there, and then come up with the things that you want to buy. So all the vending machine have its own microcontroller system over there. So better later you can be an engineer and do all this programming. Alright, this is just the family. Just touch a bit. The one that you have on the board is PIC 16F887A. You can start to memorize the name. Micro P is 68K. This is PIC 16F887A. So this is the family PIC 16F877A. You can see the names on the label over there. So PIC is a company. PIC is a brand. Just like Arduino, just like Atmel, all these companies produce microcontroller. So we are going to learn only one controller from PIC. The reason is because of the majority of the lecturers who develop the subject is from UTM. UTM is using this one in their subjects. Whereas in my university last time, in USM, we are not using this one, we are using Intel microcontroller. Alright, so this is the case now. But anyway, it's the microcontroller. It's the same thing. You just need to program it. Alright, so this is PIC. Alright, this is all about how do you want to choose. In this class, we are not giving you any choice of options. You have to use this one. There is no choices. Use this one. I give you this one, use this one. But for your final year project, you may want to reconsider what type of microcontroller that you want. You may opt any brand, doesn't matter, as long as it is very easy for you to use. Now the trend is using Arduino base. Why? Arduino base have a lot of references in the internet. You can come and search for their library, examples, everything's over there. You can download and try yourself on the system. So that's why another thing is very cheap. For example, if you want to do a small system, you may not need to buy this one. You can just buy a small one. Very simple analogy. If you are single, you may not need to buy BMW unless you are very rich. You can buy a small car, like me, I buy small car only. When I work as an engineer, for the first year, I only buy a small car, and it lasts until now. How many years already, eh? This year is going to be 18 years, my car. That is my first car, and until now, still my first car. I have not yet upgraded, soon, baby. Alright, if you want to use a new one, let's say for example, you have new things that you want to have, I think a bigger experience, bigger system, you may need to buy a big one. Maybe you can buy BMW or whatever, Audi, because you have things that you want to do that the small car cannot be used. The small car is only for the local. Maybe you have to buy a bigger one when you have family. You have to travel back. That's the reason why to choose this one. Alright? Alright, packaging is just packaging. This is type of packaging. If you are exposed to the industry, you can see a lot of packaging of the chip. This is one type of them. Packaging is a term is to package it. For example, very simple. If you want to go and buy detergent, sabun basuh, you can buy in terms of liquid packaging, dynamo. You can buy types of powder. Right? That's all the types of packaging. So if you expose the industry later, you can see different types of packaging because different types of packaging give different advantages. Right? Next. So this is another one. You can see that this is the old one. You have another company which is also produce microcontroller. Microchip is one. Atmel, Intel, Philips, Zilog. So this is another type of one. Now Arduino is the latest one. This is very old one. So we're still using the old slides, 2009. So now it's 2018. So I have to put later Arduino. Right? Alright? Just for the basic element modules that we have inside there, this is just a touch base because each of them will go through your class later. So we have the internal CPU, internal register, we have the memory, go back to this basics and memory. You have the RAM, you have the ROM, and this is timer, you have the analog to digital converter, you have the serial port, you have the input output system. Alright, so you can look over that. It's okay, one more. So this is just a family, no problem. The name of PIC 16F887A. So all the industry, when they give a name to the product, there is a meaning of that. So this is the meaning of the names of the PIC 18F887A. So yeah, different. Yeah, this is another family. Alright, so that's why I say another one. So 18F this one, you're going to learn this one. This is the types of the family that you have. Example only. You have the small car, you have the big car. You have the single car, this is MPV, something like that. So you have the small one, cheaper. You have the big one, expensive, more expensive. Of course, more expensive, more things that you can do. Right? This is just the features, no problem here. Okay, not here. Okay, go to the theory now. Theory is very boring. So they designed the microcontroller based on two architecture. So you have to memorize this architecture. So there are two types of architecture. One is the Harvard architecture. Another one is the von Neumann architecture. So look at the difference on these two architectures. Look first. Von Neumann and Harvard architecture. So from these two architecture, which one that you think that is much better in terms of speaker, in terms of usage, in terms of that one? Look at the diagram first. You have the von Neumann, you have the Harvard. Von Neumann or Harvard? This is the architecture of the microcontroller. So some of you say Harvard and not really people say the von Neumann. The reason why is I may choose Harvard is much better because it has its own root for the RAM and the ROM. They are not sharing. So you can do the communications on different parts rather than use the same root. Right, this is the architecture of this one, the architecture. So the Harvard is much better. So if they ask you about what is the architecture for the controller, this is the two one, and you have to let them know what is the best one between these two of the architecture. Alright, the difference. Now you can see on the board. This will be the same on the board. Look at the board there. On the green connector, even though you don't have the microcontroller, the green connector will give you all the labelings on the pins. There are 40 pins. I cannot remember all, but I know the function. Okay, if you look at the green connector, that one will be the same one. Is it the same one like that you guys have? Same, huh? Alright. The first pin is the important one. The first pin, you can see the first pin. That pin is named MCLR under, what do you call it? Bar. MCLR bar, betul? Dia ada bar atas tu. That is the master clear pin. Master clear means for you to reset the controller if your controller got problem. Reset, like your PC, when your PC hang, you can reset it, right? You're going to reset. Pull this one up to reset. Means you are going to make it back to its condition. So, why does it put bar over there? That means that that particular pin will only activate if you put 0 volt. That is the low active, right? You cannot put 5 volt. You have to pull to 0 volt, then your system can reset. If you put 5 volt, it will not reset. You have to put 0 volt or make it to ground, and it will reset. Okay, next one. From the pins, you can see that I distinguish there are 5 ports. We have port A, we have port B, we have port C, we have port D, we have port E. The names of the port on the pins is given as RA or RB or RC or RD or RE on the board. R means there's a port over there, it's a name. Okay, there are 5 ports. What does it function? What is the function? This port normally used for the input-output system, the hands and the leg. So majority is used on port A, port B, port C, port D, and port E. You can see that from there, port A, port B, port C, port D have 8 pins. Only port E have 3 pins. Okay. For example, I take example here. The port A0, RA0 is a port analog or digital. This is digital pins slash A and O. This is another function. If you can see the name with slash, that means, which means that that pin has particular 2 types of functions. It can be changed as another function. For example, here I put here, okay, this one, master clear is the master clear pin. This is port A, RA0 slash AN0. This pin, pin number 2, can be used as a digital input-output, which is RA0. Also, it can be used as analog input for the pin 2. If you say slash, means that the particular pin can be different types of working. It can be used for another one. Here you have 3 types. Here you have 1, 2, 3, 4. 4 functions. But normally you only use one. You cannot use twice. If you want to use twice, you have to do your own programming. Alright? So this is the overview. Now next, look at the board again on the connector. So every controller must have clock. Same goes to your CPU. Your CPU have clock, right? How many gigahertz? That is all a clock. On the board, on the connector, look at the crystal over there. Do you see any crystal or not? That crystal is next to the capacitor of C8, C9, C12, and the clock is labeled as Y1 on the board. Can you see it? Y1. All PCB board must have label. On the next green board connector, look at Y1 symbol. Y1 is the clock, crystal clock they call it. That crystal clock must be accompanied with the 3 capacitors for the filtering of the clock signal. So everyone can see on the board, Y1. So every microcontroller that you want to use must have a functional clock, else it cannot work. So this is the clock types that we have can be used. We are using, if I'm not mistaken here, we are using crystal oscillator on the board. So there are 4 types of clock that can be used. You can memorize all these 4 types of clock and its connection. For example, crystal here, you can see that crystal, next to the crystal we have 3 capacitor, right? This is capacitor. It can be 2, it can be 3. That one is to filter or make it the clock signal very good. It's the functions of the capacitor. So that is the circuit diagram. So go back to the overview. The clock, where's the clock? Where's the clock pin? The clock pin is at pin 13 and pin 14. So your clock on the board must be connected to these 2 pins. That's why you can see that the clock is just next to the OSC1 and OSC2. They put the clock over there. Okay, so far? Clear? Eh? If not clear, you can rewind back the video. So that is the clock pin. Another big thing that must have before your controller can be used is of course the power pins. Power pins is a power pins over here. They call it VDD and VSS. You must supply accordingly to the spec. This PIC needs only 5 volts to work. Direct current, sorry. 5 volt enough. That's why you are taking the electronic stuff. This is what we call electronic. Electronic only deals with DC voltage. Direct voltage at 5 volt or maybe 12 volt and finally 24 volts. Enough. If you go for EKG, you can play around with kilovolt. I do not know how many volts. something like you can die over there. This is very small for electronics. Okay, it's digital electronics. So far, okay? So the requirement is you must have the clock, you must have the power pins. Then it can work. Then you can start to do the programming. Alright? So 4 types of clock that can be used. We are using crystal clock. XTAL means XT is crystal. They call it crystal clock. So that is the connections. And that is the signal coming out from the clock. The signal is over there. Types of signal. And finally the signal will be a square form. Okay, square form. The first signal is like this, the sinusoidal. That's why they have the capacitor to make it very clear. Then you have the signal like this one. The clock's over there, oscillator. OSC1, this is a clock. Clock here and there. This is a consistent clock. How many gigahertz, how many megahertz? Okay. Now, when you start the clock, you need to learn 2 terms. You need to understand 2 terms. One, they call it clock cycle. Another one, they call it instruction cycle. Clock cycle, you can remember this, Clock cycle and instruction cycle. You are given a board with the microcontroller, for example, your microcontroller crystal is given as 10 megahertz. This is normal like your CPU over there. When you buy PC, how many gigahertz that you buy is up to the processor. Alright? So what is the meaning of clock cycle? Clock cycle means is equivalent to 1 over this one. Is equivalent to 1 over 10 megahertz, which is, they call it a tempo, right? This is frequency, right? Remember the equation? F is equivalent to 1 over T. Okay. So the terms they call it clock cycle. Another terms they call it is instruction cycle. What does it mean? Instruction cycle is the cycle time for one execution of an instruction which consists of 4 clock cycles. So, instruction cycle is equivalent to 4 times clock cycle. That is the equation. Understand? Okay, now try example here. Try yourself because we have the answer over there. Given a microcontroller with a 20 MHz crystal, calculate the time for one instruction cycle. Can you calculate now?
0.0.
Try.
0.0.
Huh? Very fast. Your calculator ready. 20 MHz. Calculate for one instruction cycle. Calculate. You have a calculator over there? Of course, you must use calculator. I cannot calculate for myself. 4 MHz clock. Mega is 6 zeros. Because you need to understand what is the term for the clock cycle and the instruction cycle.